are going to be looking at some integration here. And level 1 is going to be basic integration, and level 2 is going to be using that U substitution. But we're going to all go over that. Everyone's going to go over that U substitution together. So I have a worked out example and also some integrals that you have to memorize. I did make a note here. You must include the absolute values around. If you're integrating 1 over x, you have to do the natural log of the absolute value of x. Just keep that in mind. So our worked out example, remember U substitution is what we use when you're like, okay, I cannot easily integrate that. There are 2 separate things going on here that are the part of, if you were differentiating, you would use product rule or you would use quotient rule. And U substitution is like essentially what is like kind of undoing that. So or product or quotient rule are kind of like undoing U substitution. So when I look at this, I'll leave that example here for you guys to check out, and we're going to go over this mixed problem together. When I look at U substitution, the most important thing is to kind of identify like what should U be. Now, because this is 3 cosine of 2x plus 4, that's a little bit larger of an expression than sine of 2x. So I'm actually going to make my U 3 cosine of 2x plus 4. Reason behind that is because when I differentiate that 4 is going to go away. And I also know that the derivative of cosine is sine. It's a negative sign, so this is going to look a little bit nicer. So when I take that derivative, I get that this is going to be negative 3 sine of 2x times 2. And remember, the derivative of 4 is nothing, so I'm going to say du equals negative 6 sine of 2x dx. Now remember, the whole idea is that we're replacing as much as we can. We don't have negative 6 sine of 2x dx. We have sine of 2x dx. So I'm going to divide by negative 6. Or I'm going to do a negative 1/6. Same thing, right? So we know that that is equivalent to sine of 2x dx. When I substitute, we're going to have, this is going to be, make sure we say x equals 0 and x equals pi over 4, because now we are substituting in terms of u. So you can go ahead and sub a 0 and solve for that and put those limits in terms of u. We'll chat about that in a second. But for now, make sure that you're noting that these limits are in terms of x, not in terms of u. Now I know that u is 3 cosine, that whole denominator. So that's going to be over u. And then I also know that this sine of 2x dx is equivalent to negative 1/6 du. So I'm actually going to do a negative 1. I'm going to put that 6 here, and then that's du. I'm going to change these limits to be in terms of u because that's just going to be easier for me in general to do. So let's get this done. We know that if I plug in pi over 4, 3 cosine of 2 times pi over 4 is pi over 2, plus 4 cosine of pi over 2 is 0, so this is going to be a 4, and this is in terms of u. And then if I substitute 0, we have 3 cosine of 0 plus 4. We know that that's 1. 3 plus 4 is 7. So now those limits are in terms. We're going to say negative 1/6 u du. And then I'm actually going to say this is negative. Since my higher value is in the bottom integral, we're going to say this is 4 to 7. And I'm going to pull that negative out from that 1/6. So it's going to be a positive 1/6 u du. Again, some more manipulation. Let's pull that 1/6 out. So that's going to be 1/6 times the integral from 4 to 7, 1/u du. Now we're in a place where we're like, okay, this is actually pretty manageable. We know that the integral, we can go back and look at our rules. The integral of 1/x is the natural log, and we have to use those absolute value signs. So we have 1/6 times the natural log of u. And then we are evaluating this from 7 to 4. Put that in parentheses. So At this point, we are going to come down here and start substituting that in. Remember, since we put this in u, we don't have to go back and plug in this whole sine of 3 cosine of 2x plus 4. Because we put those boundaries in terms of u, it's going to be a lot easier to work with. So I have 1/6. We have the natural log of 7 minus the natural log of 4. And then a friendly reminder that we can use those log rules to make this 1/6, the natural log of 7/4. And there is our answer. All right, guys, so we are looking at this level 2, this u substitution practice. Now, I think the biggest thing with u substitution that I hear from you guys and from essentially everyone is that the hardest part about it is figuring out like what's u. So like, what am I actually substituting? Normally, I say like find the highest degree and substitute. When I look at this though, and I say, okay, let's say u is sine to the 5th of 2x. If I differentiate that, I get 5 sine to the 4th of 2x times cosine of 2x times 2. Now the problem with this is like this is not going to replace that cosine. There has to be an easier way. So if you ever get to a point where you're like, that is not going to substitute well at all, we can go back and say, okay, what if we say that u is going to be sine of 2x? Because we can say u to the 5th, and then let's call du is going to be 2 cosine of 2x. Well, now we're in a better position. So it sometimes just takes a little bit of trial and error, and that's okay. So right here, let's play around with this. Sorry, this is a dx, because that's the derivative of u with respect to x. So then when I come over here, I'm like, well, I don't have a 2. So I'm going to divide by 2 and make this a 1/2. So now when I replace, again, I'm going to put these boundaries in terms of u. Also, when you look at your multiple choice questions, you're like, none of those are pi over 2 and pi over 6. So let's say sine of 2 times pi over 2. Sine of pi is 0. And then we have sine of 2 times pi over 6, which is going to be, what is that, pi over 3. So that's going to be root 3 over 2. So now we're going to set this up where I'm like, my boundaries are now in terms of u, so I don't have to write x equals like I did earlier. And we're saying that this is going from, instead of a pi over 2, that's a 0 in terms of u. And then instead of a pi over 6, that's now a root 3 over 2. Now we're all in terms of u. This is going to be a u to the 5th, because that's a sine of 2x. Technically, right, you can move that outside. So we're going to say u to the 5th. And then we have 1/2 du. Remember that 1/2 can come on the outside because it's a constant, and we're going to leave that du. So d is going to best match our answer. If you were solving this fully, you could just substitute that 0 and then that square root 3 over 2 really quickly. Number 2, which of the following definite integrals has the same value as 0 to 4 xe x squared dx? Cool. So we're again using u substitution. We have an x and we have an x squared. I'm like, okay, I know the derivative of x squared is 2x. So my u is probably going to be my higher exponent. And it's okay if you're wrong. You can just go change it. So du is going to be 2x dx. I don't have a 2x. I just have 1x. So I'm going to divide by 2. Make this 1/2 du equals x dx. When I replace this, again, remember that these boundaries are in terms of x. So since my u is x squared, u sub 4 is going to be 16. This is very weird notation. U of 0 squared is going to be 0. So when I rewrite this, our boundaries are from 0 to 16. We're replacing that x squared with a u. And then that x dx with that 1/2 du. So we have a 1/2 e to the u du. Again, this 1/2 can be pulled out of that integral. So we're going to have 1/2 times the integral from 0 to 16 e to the u du. And we're going to come over here. That matches letter B. So we are looking good to go.